Hello Python programmers. In this video we will start with a CSV file and massage it a little bit. Finally we'll create a plot from that massaged data. The data is weekly East Coast gasoline prices over I think about a 10-year span. And I have it open on the slide in Excel just to illustrate one perspective of that data. But it's not an Excel file, it's a CSV file. I'm going to take a peek at it using a different tool. And I'm going to try, there we go. You can see that it is associated with Excel. It's got the Excel icon next to it. And Windows thinks it's an Excel file, so to speak. But it's actually a CSV file. So it's logically organized into rows and columns, but it doesn't have cells and it doesn't have formatting, and there are no formulas. There's no color. If I open it in Notepad++, I can see the raw data. And there's 5 header rows at the top, which we'll get rid of. The data is a date, month, day, year, comma, and then the price of gasoline on that day. We will import all of this data into Python and manipulate it. What I'm after then is a plot. The plot is intended just to give me a visualization of the ups and downs of gasoline prices. It's not going to let me drill down to a particular day. It's not even going to give me much resolution beyond just an impression of how the price changes. Now I have provided for you a solution to what we're about to talk about, and I misspelled solution. How about if I fix that? So as we go through it, you can follow along with me, and I'll just talk about what we're doing, demonstrate some techniques for you, and in the end we'll end up with a plot. The first thing I did was write a little logic to open the file and manually read it into a list. But before I did that, as you might expect, I have my import statements in a cell. So don't ever forget about that. You've seen me forget about that many times. Make sure you run that cell to get those libraries into your environment. And you don't have to run that cell again unless you hit restart the kernel, which clears out anything you've imported along with all your variables if you've created any, plus any other environment settings you've made. But as long as you don't restart the kernel and nothing goes horribly wrong, you don't have to import a second time. All right, my little snippet of code in the second cell attempts to open the file. It's opening it for read, which is a little bit faster than opening it for write, and probably doesn't lock it depending on your operating system. And then I can create an empty list, open and close square brackets, put a comment here, empty list, open the file. I'm sorry, the file's already open. Create a reader object using the CSV library, and then store that reader object in my variable called reader. This tells the CSV library that my file is delimited by tabs, and the file is available through this variable called file. You might not be able to see that over on the right-hand edge of the notebook, but when I did that with open, that put what we call a file handle or a file pointer into that variable called file. That's an arbitrary name, file. I just made it up. And then I told the reader that, hey, here's this thing called file. It's available to you. It's open and ready to go, and you can begin processing it. So the CSV Reader object allows me to step through the file one row at a time. Again, row is an arbitrary name. I could call that whatever I like. For each row in the table, file, I append it to my list. So I'm not doing any processing beyond consuming the entire file and putting it into my list. I'm not filtering it, I'm not deleting anything, no data type changes. And then if I wanted to, I could print the whole thing out, and we don't want to do that in this particular case because the file is rather large. If I open it in Excel and do a Control End, there are almost 1,500 rows. Therefore, I don't want to open that. I don't want to dump that into my Jupyter Lab notebook. I could, if I wanted to, just pick a random row. I could print row 100 to give me some confidence that, yeah, I'm getting what looks like data. How about if I run the first cell, which I guess I already did, but I'll do it again. Run the second cell. Now I have my data stored into my variable data, and I see that the 100th row is 6/17/2019, June 17th, 2019, and the price of gas was $2.633. Don't you love the way they price gasoline? And if I wanted a little more validation, if I still wasn't quite sure, I could scroll down to row 100 and see. And there it is right there. But I appear to be off by 1, and that's because I'm indexing from 0. So what I really want is 6/17/2019. So that's actually going to be the 101st physical row. Let's put a note here. 101st physical row in the file. And that includes the header rows, which we haven't gotten rid of yet. So that's 101. So that's going to be right there. 6/17/2019, 2633. There it is. And you don't need that, of course. That's just a little bit of confidence builder. To drop the first 5 rows, I can use list slicing. So I'm saying start at row 5 and go all the way to the end, including the very last row. Give me that slice, and then I'm going to store that back in my original variable again. I'm just overwriting the reference that I started with the reference to this thing that I got after I sliced it. That gets rid of the first 5 rows. If I wanted some more confidence, I could do a print on data sub 0. Let's run that cell. Now data sub 0 is 4/12/2021. Let's see how I did. And if I go back up to the top, there's 4/12/2021. That's the first true data row after we've gotten rid of all the headers, which I don't care about. If you think about what we're doing from a macro perspective, we can do a lot of this just in Excel. We could manually go in and delete these rows by just saying delete. but that's not automating the process. The purpose of Python is to be able to write a Python program that I can run 527 times a day if necessary, and not have someone there with a knowledge of Excel or the time to spend doing that data manipulation. I could also write an Excel macro to do this. I could record the steps that I use in Excel to manipulate this data, and I could also get the same graph out of it too. But I think at the end, when I came up with a graph, I would have less options with that graph than I do in Python. So there's a lot of overlap between tools, and the tools that you select are going to be driven by what kind of automation level you desire and what you have to install on that target machine. I mean, I'm going to need Excel in order to do this in Excel. And Excel, I believe, does cost money. So that's one consideration. All right, I do not want to save this data back. I just want to discard it. I did delete 5 rows. I do not want that to be permanent. So I'm going to hit Don't Save on my spreadsheet. I'm back in my notebook file. I did the slice operation. I'm confident that my slice worked. And I could actually, if I wanted to, I could even print the length of that. And I don't want to slice it again though. See, now I got a problem. Because if I slice it again, I'm going to lose 5 more rows off the top. Not the 5 header rows. Those are gone. And I stored that result back into the original variable, so I don't have the original data set anymore. I have the data set with 5 missing header rows. And if I add this print statement for fun, then I run the whole cell again, and I'm getting 5 less rows at the top. And every time I run that cell, I slice off 5 more rows, and pretty soon I've really corrupted my data. What I probably want to do then, and I'm just trying to give you ways to think about writing the code efficiently and to save yourself as much grief as possible, is I probably want to add another cell and put my print statements in there. That way I only ran the slice once, and I can run the print statements, which are non-destructive, as many times as I like. All right. Have I run ahead of the slides? I probably have. We talked about studying the data. Once we've done our processing from the file, we have a list of lists. So we've sliced. We verified our slice. We're confident that we sliced just the right amount off the top of the data. Now we start to look at the data. And as is, it might not be as good as we want it to be. Because remember, when you read things in, everything comes in from a CSV file by default as a string. Even though it looks wonderfully numeric, the CSV reader thinks it's still a string. And if I print it out, as you can see on slide 5, it's got quotes around it. If I print the first row, the first element in that list of lists, it's 2 strings inside of a list. Now, I'd like to do math, probably, on that gasoline price, that second value in that list of lists. And I can't do math on it very easily if it's still stored as a string. And the first element, which is a date, I might end up wanting to do some date manipulation on that, and having it stored again as a string might be problematic. So it's good to know how to fire up list comprehension and do some data type conversions at this point. What I've decided to do then is split my data on the comma. That comma is inside the string. I'm going to tick up just a little bit and refer you to little bit higher up in the notebook that we already talked about, notice the whole element is a string. So that list is a list of lists. The list is a list of lists, but each element in that list of lists is a string. So it's date, comma, gasoline amount, all wrapped up in one string. So the first thing I want to do, if I have any hope of converting that amount to a number, is to break up that thing into two strings by splitting on the comma. And that's what I've done in the code that I'm highlighting here in the notebook. I call split on a comma for every item X in the list of lists. So that goes through every sublist and splits it, and then builds that back into a new list. So look at the subtle difference between the result that I got when I print new data sub 0 and the result that I got when I printed data sub 0. One is a list containing one string, the other is a list containing two strings. Very subtle but very important. And also, again, one line of code. So if you're experienced with another language like C# or even Java, then you might say that we would have to write a loop to do this. But we have this list comprehension syntax in Python, making it much easier for us to do this in one line of code without even having to write a for statement. So at this point, I have a list of lists, and each sublist in that list of lists, each list in that list of lists is two elements. They're both strings, but they're separate now. They're not the same string. So I'm going to write list comprehension to convert the second element in each sublist to a float. And that is what we're looking at here. And my strategy is to process every sublist. And during the processing of each sublist, I convert the second element to a float, and I preserve the first element. I don't really care if it's a character string or a date at this point. And then I build that into a list. I end up with another list of lists, but each element in that list of lists is a string containing a date followed by a float, a numeric data type. Again, one line of code and then a print statement to check my work. If you're following along at home, be very careful to observe the difference between those three print statements. When I print data sub 0 all the way at the top of my notebook there, I get one string with two values separated by a comma inside that string. When I print new data sub 0 right in the middle of that page, I get two strings separated by a comma. Finally, at the very bottom, when I print new data sub 0, I get a string followed by a floating point number separated by comma. Now I'm going to start working towards my plot. And my plan here is to step through every element in my newly sanitized data and create two lists from that data, my X values and my Y values. And this is just the way it makes sense to me. You could do this with a list comprehension, but it's a little bit beyond my complexity level, so I just do it with a for loop. After I come out of there, as my double check, I simply print the first value in the X array and the first value in the Y array, and they look the same as everything else I printed, except now they are separate in different arrays, and that's how Plot knows how to deal with them. So we're getting close now. After all this hard work, we're ready to plot. We're going to create a plot, calling the plot function. And the two arguments there are taken to be by the plot function the set of x points followed by the set of y points. Or better said, x values followed by y values. Then I call plot.gca. Now, if you think about a plot as being a set of components that make up the plot, don't think of it as one big monolithic entity on the screen. The GCA function gives you the axes of that plot so you can manipulate them. By calling GCA, then now I have in AX, I have a reference to the set of axes in that plot. And then I can manipulate the axes programmatically before I show the plot. Think about it then from top down. The first line of code in the cell creates the plot. You can't see it, but it's been created in memory. It has axes, it has color, it has points and tick marks and labels. But now I need to manipulate the appearance of that plot before I actually display it to anyone. Therefore I say, hey, GCA function, give me a handle, a reference, a connection to the axes. And then I can drill down and do things to the x and y axes. In this case, what I want to do is I realized there were way too many dates on that x-axis. So I set the collection of dates on the x-axis to nothing. All the dates are gone. There were just too many of them. And then I know that the plot itself has a property called xLabel, and I can call a function that will set a value for the label along the x-axis. I can call a function to set a value along the y-axis, which I set to be USD for United States dollars. And the plot also has a title property, which I can change by calling the title function. Finally, I call show because after all that hard work, I definitely want to see what I got. And there it is. A very useful visualization of what the price of gasoline has done for about 20 years, almost 20 years. To show you the value of turning off the tick marks, let's comment out that line where we turned off the x-axis tick marks. It will be the intention now of the plot function to display every date as a tick mark over almost a 20-year period. And it's trying. You can see it's taking a lot longer. There's a lot more going on here. I'm back. You can see that I got a big mess. It simply created what appears to be almost a black bar along the bottom of the plot, but is actually the attempt to render way too many tick marks. Therefore, commenting out that axis was a good idea. You can experiment with that, and you can actually put values in here. I have not done this before. Let's just try it together. Since we're going from 2021 down to 2020, down to 2019, down to 2018, we'll just stop there. You'll see that it, oops, maybe I should, didn't get any. Let's see. That was a guess on my part, folks, to be honest, and I got nothing out of it. I don't know why. Okay, we will not pursue that any further because I don't know what happened there. Just trying to get cute. Anyway, we have a decent plot. We should quit while we're ahead. And that brings us to the end of this slideshow. So I hope you got a feel for using list comprehension to manipulate data, and reading a file in from a CSV file. So, see you next time.